Hi, welcome to Physics for Us. And today we will be dealing with this electrostatics. We will be discussing some basic concepts and we will be solving some problems which will support your NEET preparation, right? And as we know, electrostatic deals with the static charges, right? Static means which is the charges which is not in motion, right? It's in rest position, right? And static charges we know, and static charges it has charges have some properties, and the properties are they possess mass, whether it's a proton or electron. It has some mass in it, and it obeys superposition principle. Suppose we have two charges, you can add it and you can tell it as plus q plus q is equal to 2q, right? And it obeys uh, conservation law, and the charges are quantized, right? And these are the things which you know. And there are two types of charges which is nothing but plus q, or sorry, it's a positive charge or negative charge. And as we know, like charges repel each other and unlike charges will attract each other, right? These are the properties of these two, how they interact, right? These are the charges which we know, right? These are the things which uh, given in our textbook as a basic for the electrostatics, right? And we are going to use some formulas in electrostatics. For this video we will be discussing up to Coulomb's law and electric field, and we will be using another formula. We will be discussing that in our next slide. Okay, let's get into the formulas, right? And these are the formulas which we are going to discuss. And q is equal to Ne. This q is the charge, and E is the charge of electron, N is the number of particles, and F is a force, which is nothing but this is a Coulomb's law. F is equal to k q1 q2 by r square, and q1 q2 are the charges and r is the distance between two charges, and k is a constant which we know k is equal to 1 by 4 pi epsilon naught, right? This is the constant. We can replace it by a value 10 into 10 9 into 10 power 9. Okay, and using this, and there are other formulas which can be related with force, which is F is equal to ma, and please note F is a vector and A is a vector. Here F is a vector and F is equal to minus g m1 m2 divided by r square. These three formulas can be related. That is, we can equate as F, right? For example, we can write it as k q1 q2 by r square equal to ma equal to minus g m1 m2 by r square. All are forces, which is the left hand side is force, right? We can, this is the most important thing you have to know while solving problems, right? And here we have E is equal to F by Q, which is nothing but electric field, and in general force is measured in Newton, and charge is measured in Coulomb, so we can write Newton per Coulomb as its unit. As you know very well, F is measured in Newtons, and we can relate E and F, that is a force of attraction or repulsion between the charges in the electric field. Using this relation, E is equal to F by Q, and we can replace it by E is equal to KQ by R square. As you know very well, K is equal to 1 by 4 pi epsilon naught, which is 9 to 10 power 9, and both are inverse square laws. 1 by R square there, right? Both are inverse square laws. Okay, these are the formulas which you need to solve problems in electrostatics, particularly using Coulomb's law and electric field. Okay, today you will be discussing at least 4 to 5 problems. Okay, let's get into problems. Okay, here we have a first problem. Here you can see that q1 and q2 is given, and force between them is given. Okay, before solving that, you have to know what is given and what they are asking, right? What they asked, what must be the distance between the point charge, that is, there's a q1 and there is q1 and q2, and what is the distance between them? Q1 is some value and q2 is some value, right? Is given, and you have to find the distance, and force between them is also given. Okay, that's the scenario here. As we know very well, the force q1 and q2 distance are related by a equation called, or law called Coulomb's law, which is nothing but F is equal to k into q1 q2 by r square, right? What we have to find the distance for the time, it's r, right? So we can write r square equal to k into q1 q2 by r square. Sorry, just a minute. q1 q2 by f. All the values, all these values are given. q1 is given, q2 is given, f is given, and k is a constant which is given already. We know that already, 10 power 9 into, which is 26 microcoulomb, and we can replace it with the help with the in the standard in coulombs, which is 26 into 10 power minus 6 into minus 47 to 10 power minus 6 divided by just f, which is nothing but 5.7 Newton, right? On solving this, if you use a calculator and if you solve this equation, and you will be getting, which is nothing but r is equal to 1.38. Please note, you have to find the square root. On solving this, you have to find the square root of this one, right? Then only you will get you will be ending up in this equation, right? So in this value, so this is the r, this is the distance between q1 and q2, right? In general, it's in we wrote everything in standard international units, so we'll be getting in meter because it's in coulomb, it's in Newton, and this is also in 1 by 4 pi epsilon naught, just in standard international units. So this will be, we are getting r in meter, right? This is all about this problem. Okay, next, and here we have a problem. This is a simple problem, and here we have a, in the return stroke of a typical lightning bolt, a current of 2.5 into 10 power 4 ampere exists for 20 microseconds, and how much charge is transferred in this event? And this is the, here we have to use a formula, which is I is equal to q by t. As we know, this is the relation, this is the equation for the current. Okay, and here ampere current is given, and microseconds the time is given, and in the lightning stroke we have to find how much charge is transferred. We have to find q here, right? First of all, we can write q is equal to I into t. This I is the current, 2.5 into 10 power 4 into 20 to 10 power minus 6 seconds, right? Please note, while solving problems, please use SI units. Okay, once you solve this, okay, we have 2.5 into 20, we will be getting 5 here, and we have minus 6 minus 2, which is 10 power minus 2 coulomb. Okay, the coulomb of charges of 5 into 10 power minus 2 coulomb is released or transferred during this lightning stroke. Okay, here, as we discussed, these are the problems which requires numerical calculations, right? We have to understand something from, we can understand something from this problems, but the problems asked in examinations like NEET, JEE, mostly they won't have any calculation part. Rather than, we have to think logically, right? So far, okay, let's get into the next slide, and we will start explaining that some issues here. Okay, fine. Suppose a question is asked. We know, which is Coulomb's law, F is equal to q1 q2 by r square. R is the distance. If r is doubled, right? If r becomes 2f, sorry, 2r. It is, if you have a 10 centimeter r and it becomes 20 centimeter. What happens to what will be the result of force due to this change. Okay, this kind of questions can be asked. That is, for example, F is equal to, these are the constant things, we don't want to bother about this, so we can write as it is F1 Q1 Q2 by, instead of R we have to use 2R and we have square here, right, which is F is equal to, instead of this will become 4R square, right? So what will happen, just K Q1 Q2 by 4R square. If the distance between two charges doubles, then the force becomes, what happens there, 1 by 4th, right? Force will become 1 by 4th, right? For next, if they ask from this question, if F is equal to F4, F by 4, then what will be the distance between the, what will be the distance between the two charges? They may ask like this, right? Okay, and here we have another problem. A charged particle of charge 3 into 10 power minus 6 coulomb is 12 centimeter distance from a second particle, just minus 1.5 into 10 power minus 6, and you have to calculate the magnitude of the electrostatic force. This is simple. F is equal to 3 into 10 power minus 6, and here we have minus 1.5 into 10 power minus 6 divided by 12 into 10 power minus 2 whole square. Okay, and here they asked magnitude of the electrostatic force between them. Magnitude, if magnitude is asked, then what you have to do, we are just neglect the negative sign, and F will be 2.8 Newton, 2.81 Newton precisely, right? Please note, there is, find whether it's attractive or repulsive force. If the question is asked as whether the force is attractive or repulsive, okay, what do you have, how can we find whether it's attractive or repulsive? For example, in force, if you have negative sign, then the force is attractive, right? If force has positive value, right, here you can see that the force is nothing but minus 2.81 Newton, and the absolute, obviously the force is attractive. If we got it as 2.81 Newton, if this is positive, and you will be getting 2.81 Newton, and this will be the repulsive force. Okay, this will be the repulsive force. Please remember, this is the most crucial point. Even some questions, you can see that they used to ask whether it's a repulsive or attractive force. By seeing this signs, you can say that whether it's electrostatic, that force is attractive or repulsive, right? These are the things which you have to know, right? Here comes the some discussion we have to do here, right? So far we discussed I is equal to Q by T. These are the equations which we used in solving problems, right? And problem relating to the electric field we'll be discussing in the next slide, and we have two more problems in electrostatics, and we'll do that after finishing with some discussion in these formats, right? And F is equal to Q1 Q2 K into Q1 Q2 by R square, and E is equal to F by Q, and E is equal to F by Q, and we have different formulas for force. F is equal to ma, F is equal to minus G m1 m2 by R square, and here also you can see that negative sign, which is nothing but the gravitational force is an attractive force, right? That's why you are getting minus a. This is nothing but Newton's law of gravitation, right? This is Newton's second law, this is Newton's law of gravitation, and these are the forces, right? And E is the electric field here. Okay, now we have some questions to ask. Suppose if you have a electric field, if you have a electric field, right, which is nothing but F by Q, and once you substitute for F, you can write capital Q divided by K into capital Q divided by R square, right? And these two, it is called as, particularly Coulomb's law is also called as Coulomb's law, which is called as inverse square law. Inverse square law, right? Because we have a square in an inverse, right? Similarly for this gravitational force, right? It's an inverse square law. Okay, what happens if you have a suppose, how can we find the ratio of K is to G? K is the constant, which is nothing but 1 by 4 pi epsilon naught, and G is the gravitational constant value, right? They will be asking these kind of questions. These are the constants which is given in your examination, right? You have to relate K and G, right? You know that it's simple. K is K, and the gravitational force, it has unit charges and unit masses. Unit charges and masses. Okay, and we can relate K is equal to K Q1 Q2 divided by R square M1 M2 R square minus G here. Here for the time being we don't want to confuse it with the negative sign, so Q1 Q2 all are 1. I made it 1 here. Now to find K is to G, we know K is value 9 into 10 power 9, and G has some constant value, and you have to just substitute the value. You can find the ratio, and you can find the ratio between K and G. Okay, suppose if you have a question, if R is doubled, what will be the electric field between? Will be the electric field. It has a charge Q. Okay, these are the same things. For example, E is equal to KQ by R square. If R is doubled, then you have to put R is equal to 2R, so KQ by 4R square. So you can write E is equal to, this is nothing but E, I can find 1 by 4 here, so it will become quarter times the initial electric field. Okay, this type of question you can expect, right? These are the formulas. You can find n number of questions like this, right? By manipulating some values or some changes, you can these are some ideas. You can while solving problems, you can use these things, right? Okay, next. Okay, let's get. Okay, here you have a practice problem. Just solve it and comment your answer in the comment section. Another problem. Okay, this is the problem which we are going to use some new type of substitution here. From the known equations itself we are going to do this, right? How many electrons should be removed from a coin of mass 1.6 gram so that it may float in an electric field intensity of 10 power 9 Newton per coulomb? Suppose we have a coin which has a mass of 1.6 gram, and they are asked to find number of electrons. How many electrons are required to float in the electric field? Okay, as we know very well, F is equal to, we know the electric relation between electric field and electric force, which is F by Q. So we can write F is equal to EQ. E is the electric field, Q is the charge, and here they gave mass, right, which is nothing but mass here If you know that F is equal to ma, here we have mass here. Force and mass can be related, so we can relate these two equations and write it as eq, which is electric field, into q is equal to ma. And you know that E is given this 10 power 9 Newton per Coulomb, and Q is equal to Ne. Q is equal to Ne. So we can write Ne, instead of E we can substitute 10 power 9. M we know 1.6 into 10 power minus 1.6 into 10 power minus 3 kilogram, and A is nothing but 9.8. This is the acceleration due to gravity. A is equal to g and g is equal to 9.8. And once you find n is equal to 1.6 into 10 power minus 3 into 9.8 divided by 1.6 into 10 power minus 19, minus 19 coulomb, which is the mass, charge of an electron, into this will in this side 10 power 9 here, 10 power 9 here, and this will cancel this one, and here we have 9.8 to 10 power minus 3 minus 19 plus 9, you will be having 10 power minus 10, plus 10 here, and we can get 9.8 into 10 power 7 number of charges or electrons should be removed in order to get the coin photon in an electric field intensity of 10 power 9 Newton per Coulomb. Okay, thank you for your attention. We will see some new problems in upcoming classes. Thank you. If you like this video, please comment and subscribe my channel. Thank you.